Are many of you familiar with that topic, the whole idea of how are you going to sequence things when you're writing DAX, right? The reason I've always kind of struggled with it is because there's actually multiple things that kind of play into it. One of them is, and I'm going to go through each of them, but sort of what is the order you put your parameters in a function? In other words, you know, what is the actual sequence so that you're putting, if it's calculate table, the first parameter is actually a table. So there's that element of order. And then there's really, how do these functions sort of evaluate on their own? Do they do kind of an intersect or do they do an overwrite? So that's a whole nother area. And then, you know, also like which table functions are better to use? And like, so what you'll see as I go through it. So there's kind of many parts playing to this. And so because I am kind of like break it down a step at a time kind of girl, we're going to be going through each of those things, but I also wanted to say something that I have been doing a lot of lately, which is taking, there's a lot of stuff, so ignore it pretty much. Let me get it a little bit smaller, not quite that much smaller, but I'll just, and we'll sort of let you see it a little bit bigger later, but I'll show you the small version. What I'm doing is in something called Lucidchart. Oh, I don't want to get away from the camera, I'm not sure.
Give Lucid
in Lucidchart, you can actually sort of make flowcharts. So Lucidchart is a really nice, much better than Visio, way of sort of representing a bunch of concepts together. So when I was trying to think about order of evaluation, and I was thinking, how would I even talk about it? Those things that I was mentioning, sort of the having to do, well, let me just expand this. Having to do things with how do you order a parameter? You know, what is that like? It's kind of like what is the order of operations in math? I mean, I kind of have all of these little tricks that are in my sort of way of looking at how I'm going to think about this concept. And the reason it's kind of important is DAX is very conceptually driven. And unless you can kind of wrap your mind around those concepts like context transition and you know, order of operations, you will get lost, right? So these are my kind of elaborate cheat sheets to keep all of these things in mind. And in this particular situation, the two sort of important flows, and it doesn't matter if they see me all the time, is the order of operations, like how are you going to nest functions? And we'll talk specifically about that. But also, how does the operator in DAX behave itself? Does it do an intersect or an overwrite when it's looking at functions? So you'll see as I kind of walk through it, but I really wanted to illustrate to you, you know, sort of a nice way to get the way you might want to start thinking about cheat sheets for yourself. Because I tell you honestly, when I come back to these, they are incredibly helpful for walking me through a difficult concept. So, like for example, I have a couple cheat sheets for many-to-many modeling, right? Because there's about 16 steps you have to kind of think about when you're doing a many-to-many design. So anyway, that's a pitch for cheat sheets. Okay, order of evaluation. Order of evaluation, or is it sort of the parameter order? And that's a little easy to get confused. This is a parameter order, right? Okay, I have date diff, it's a function. You have to have a parameter 1, which is your start date. Then you have an end date, then you have an interval, right? Pretty straightforward. And most of the time, they're kind of like you'd construct a sentence. You know, if, you know, I am hungry, then eat. If not, don't eat, right? I mean, that's sort of the kind of the logical things you try to find when you're using DAX, and they generally will use, right? However, and you know, I was sort of thinking, that's not really the same as the order of operations. So you know, in math, right, the way you sequence it is incredibly important to getting the right answer, right? So, and that's kind of a convention. There's a convention that, you know, smart people thought of a long time ago of what you do first. You add first, or whatever that sequence is. You do what's in the parentheses first, exponents, et cetera, right? So you have to kind of, as opposed to saying I could just go 1, 2, 3, 4 in my order, you have to respect that they're going to be conventions, and some of the conventions are what I'm going to introduce you to. So usually the order of evaluation is the same as the parameter. You know, a switch statement. If it's economy in pink, then give me economy pink. If not, do silver, etc. So usually that's pretty straightforward. But order of evaluation really becomes an issue when you're nesting stuff. So why would I even speak of nesting? And so we're going to kind of take a look at that in depth. What we're going to do initially is look at a filter function where you're just saying, I have two questions. I want to know the sales where the quantity was greater than 1, and I want to know the sales where the country was, Mexico or something like that. I kind of have two questions. That's pretty easy to do. Give me the sales, and then give me an and clause where this and this, right? You could certainly do that. You could also do that by nesting, right? You could sort of ask one question first, give me all the sales, that are France, and then go and say how many of them where the quantity was over 1, right? You could ask, and the reason I'm going to be giving you very simple examples in this thing, but in fact, this ability to kind of ask two questions in one do kind of, how many of you write SQL? So, everybody. So, to write a correlated subquery, right? I always love to throw that in, just I love to say that.
I taught you
correlated subquery, right? What?
I taught you that.
Yeah, you taught me that, and I don't know what it means, but I always say it. So anyway, but you need to be able to kind of ask complicated questions and then ask a question about your complicated question, right? So even though the examples I'm going to give you are stupid, think smarter, okay? So filter. Filter is a function, and we all know that filter can also be used to be a table, to say, and I'll just give you an example. So this is where filter, I'll just use the pointer instead. Sum x is the very first parameter it's going to take is a table, it needs a table. And so you're looking at filter here, which is actually acting as a table. So instead of saying sum x on my first parameter being sales, and I want to look at quantity times price as the second parameter, I'm saying, no, I actually want to make a very special table that's filtered down to the sales quantity is greater than 1, right? So just plant that in your mind, because we're going to be looking to it. If you are going to call more than one table function, sort of what is the best order, right? If you're going to do this kind of equivalent of a correlated subquery. So what am I doing here? I've got a sum x on the outside, then I've got a filter, and then I've got a calculated table, because I sort of want to ask this I sort of want to create my little subquery using calculated table to say, hey, look, I only want sales where the unit discount is 0, right? And then I'm going to ask another question of that. For that subgroup that I've got, I want the quantity is greater than 1, and oh, by the way, after that, I want you to do this particular expression, right? So the calculate table, now, when you're using filter, it will behave kind of well, It's going to do the first thing first, right? It's going to actually, it's the innermost, and it's going to give us the rows that have no discount. And then the outermost will happen next and give us the quantity over 1, okay? So filter is very straightforward, is relatively straightforward. So why, so a couple things, like I'm thinking, okay, how do I even figure this out? How do I know if I should use filter and filter as the second parameter? I mean, filter and calculate table are both kind of doing the same thing. Do I choose filter, filter, calculate table, calculate table, calculate table, filter, or, there's like, who writes the rules, right, of what you're supposed to choose? So a really good thing to do is to befriend DAX Studio. So somebody was asking about SSAS. I'm a really big fan of working in SSAS just because I do it a lot. So this is, how many of you have seen the SSAS interface? What's, oh, that's good. Some people, so, what is SSAS? Does anybody want to say what that is, as opposed to Power BI?
The original.
It's the original, spoken by the original the original SSAS guy. So, SSAS is kind of like a beefed up, muscular version. I shouldn't say that, because that's not really true. But SSAS was, in the old days, kind of the idea was Power BI was a little bit more informal. SSAS was where SQL Server Analysis Services, Tabular, was where you would go to do really good row-level security and everything like that. Well, Power BI is kind of like really beefed itself up. And in fact, probably SSAS, eventually is going to be secondary to Power BI. When I space Power BI, I mean Power BI Desktop, right? Is that familiar to people that you have that concept? Okay. However, I work a lot in SSAS. And so this is just AdventureWorks on SSAS, and I work a lot in DAX Studio. So how many people use DAX Studio? Okay. So DAX Studio is now boring, looks like, well, you all work in Management Studio, right? So you're used to this kind of boring interface. On the left-hand side is the models that that you have available to you to look at. This is where I'm going to be writing the queries, and I'll make these bigger. On the bottom are there's output panes, and in a minute we're going to look over at the last tab, which is really the exciting tab. If you want to understand DAX, you've got to learn DAX Studio. It is incredibly, well, actually, Brian has a really cool trick that can kind of help you not have to learn DAX Studio. But it is incredibly important to unpack what is in the inside of your DAX functions. So, warm up to the idea because you're really going to want to use it. So, I said all of that as a prelude to say, what we're looking at here, and let me make it just a little bit bigger if I hold the control. Oops. Okay. So these first three functions are basically completely identical, okay? So the first one is doing what I said in AND. I'm just asking a simple question. I'm saying, tell me sales where the currency key is 19. Let's say it's French, right? Just happened to be that I needed to use a currency key. And the tax amount is greater than 0. Now we know in France, it's always going to be greater than 0. So that's kind of an irrelevant question, but anyway, that's using an AND clause. The second one is, the outer one is filter, the inner one is calculate table, right? And the order is still, sales currency key is kind of coming first, and then sales tax amount is second. The third one is filter filter, right? And partly I was just messing around, like, what's the difference? Why would I choose one rather than the other? Well, performance is a really important question for you to ask. Maybe one of them's really fast, and the other one isn't. Not only maybe is filter and calculate the perfect combination that's really fast, but maybe I have to put the second, the tax amount first and the currency key second, right? You see, these are the kinds of questions you're asking when you're asking about order of evaluation. How do I do it intelligently for performance and to give me the right answer? So in DAX Studio, I literally came in here and just sort of set up all the different options and started playing with it. The single question I really want to ask, well, first of all, I want to know, is it going to give me the same number of rows? And they all do. I won't bother you with that. But what I really want to know is this thing, how fast is it going? Right? I want to know, and I don't want to know by just eyeballing in Power BI and seeing, okay, that seems a little faster. I want to be able to see the speed, right? So optimization, and the reason I'm sort of labeled this as optimization, is the guts of learning optimization is learning how to sort of run these queries and look at the timing of it, and also learning about the storage engine and the formula engine. So watch what I do. I'm going to choose this button, server timings, and I'm going to, over here, go to the server timings. I'm actually going to clear the cache because it has a bad habit of remembering what the last thing was. And I'm actually going to set this up so that it runs and clears the cache. So I'm going to run this evaluate statement. So again, for those of you that are new to Power BI, why is she using evaluate? What that's got to do with anything? Well, you all look like you knew SQL. So it's effectively saying select, run this for me. But this isn't actually a DAX measure. It's kind of the guts of part of a measure. So I'm going to hit run, and you're going to see that it took, actually the first 46 was just clearing the cache. You're going to see down here, and I don't know if I can make this part any bigger. I don't think I can. I'm going to step out of the camera, sorry. In this corner, there's these two really exciting colors. Formula engine, storage engine, and this is the number of milliseconds that it took to run that query. What you're ideally trying to do is stay away from the formula engine and put as much into the storage engine. Think storage engine is the compressed world. It's really smart. Actually, storage engine is really dumb and really fast. Formula engine is really smart and really slow. And I just think that's so cool. It's kind of like the mind, you know? On the dumb things, it's really fast. And on the smart things, it's slow. Okay, so there you have the and clause. Took 609 milliseconds. So I said, well, okay, let's restructure it to ask the question in a nested way. I'm going to have evaluate filter and then calculate table. Boom, I run that. It's going to clear the cache, so that's 45 milliseconds. But then 620, it's almost the same, right? Then I go down to evaluate filter. I run this. And I can tell you in advance, it's almost exactly the same. In fact, I'm not really learning anything here. I mean, I'm not. And what I'm going to do is that I'm just going to spare your time and sort of, well, I'll actually do one filter at a time. Later on, I say, okay, well, what happens if I switch, you know, tax amount first? What happens if I move these around? You know, none of those make a difference. So, but we had two questions, right? So if we look at these two, so I said, well, okay, let's break them apart. Let's just evaluate in the sales table everything where the taxes amount is greater than 0. And then let's do a second one that says everything where the currency key is 19. So these are what I've coupled together. We had 609 or 643 milliseconds. What is your guess that this one is going to be? Do you think this one will be faster or this one will be faster when we break them out?
Second will be faster.
Which one?
First one will be faster.
First one will be faster? How many think the first one will be faster?
No.
Oh, how many think the second will be faster? Okay. The second will be faster because it's got to go and run, you know, this one has to go and ask that question of every single row, and it takes, okay, 6,000 milliseconds, right? Because it's asking. However, the currency, and this is the beauty of compression, right? The currency is, you know, there's just not that many currencies. There's only 19 or 20. So it compresses that down. It doesn't have to add every single question. Yes, I hope you're not going to make me answer a question that I don't know.
Well, if you change the sales currency key to be a greater than function like you did with the sales tax amount, I mean, is that going to...
I'm sure it would slow it down. Yes, but I think, no, actually, maybe not, because it's what you're struggling with is that 19 numbers compressed down is very fast.
Yeah.
The sales amount for each of them, which might be pennies off, is slower. That's my guess. But my point is that you can see. Now, what's interesting about this, the first one took us 6,000, and the second one took us 615. Now, what happened when we coupled it together? It was like in the 640s, right? Isn't that interesting? So it went to the engine is so smart about optimizing that it went to the fastest one, compressed it first, and then did the other one, which was much less data, right? So it's really interesting that way. And you can actually see, you'll see in a minute how when I sort of put these together, and I thought, well, of course then, wouldn't I need to put currency first, whether first means happening in the outer or in the inner, but in fact, that doesn't make any difference at all. So, yeah, I'll just kind of whiz it. Let's see, was I going to go over this one? Yeah, I think these were ones where I was just messing, and you can see that the numbers were the same. I was just messing with the order. Now, so I said filter. Filter does the innermost first, or the first parameter first, right, and then the second one. Calculate and calculate table are completely different in their order of evaluation. So you have to really think deeply about those. And we're going to go do that in a second. All right. So that was all about the innermost filter. So, yeah, this is one of my favorite lines about calculate. So calculate, I think the guy who wrote it said, you know, basically you should spend 5 hours in your first, he said something about a slide where you'd spend 5 hours just on doing a slide on calculate. So calculate, and I'm just going to throw this out here because it's important you to be reminded of it. We're not going to spend too much time about it. It does these 4 things. It first goes and find, hey, am I in a row context? If I'm in a row context, I'm going to translate it to filter context. May not always be, but it could be if it's sitting in a calculated column, right? Boom, that's the very first thing it'll do, or an iterator.
Calculate or calculate?
Both of them will translate a row context into a filter context. Then it'll propagate that filter context, any related tables, which is different than the propagation from the filter context coming in from what your user said. It will modify the filter context according to the parameters passed after the first one. So the first parameter in calculate is what? It's measure, right? Basically, it's going to do the measure last, right? We sort of know that. And then it's going to evaluate the first parameter, okay, as in the resulting modified filter context. So it will do that every time. I have had to study this kind of sequence a million times till it's sunk in, but I'm just introducing it to you. So calculate is different. They will evaluate the first argument after all the other filter arguments. But what happens when you nest? Okay. So on
and calculate is even different.
Calculate?
Calculate.
Oh yeah, right. It's a special kind of harmonious one. Anyway, on the left-hand side, very straightforward. You know, the unique values of color. I want to get the color that's red. But now when I do a nested calculate, which do you think is going to trump? Is it going, when I run this, is it going to be red or is it going to be blue?
Red.
Red, we have a vote for red. So I'm going to come down here. Blue. Okay, so this is the calculate table with the values of the product color. The product color is blue, and then the outer one is red. Okay, oh, now we have to go to results, not to that. And I'm going to run this. Blue. Okay. So blue, well, and I'll show you, and this is the other interesting thing that happens. So it returns blue. As blue comes, let me see if I can make this a little bit smaller. Oops. So blue comes second, is overwriting red. Sorry, I can't get it exactly right. There we go. All right, so this is, remember where I said you have to think about overwrite and intersect? Calculate overwrites, right? So we have the two, we're asking two questions of the same column, right? We're saying, you know, give me all the values where the product color is blue and it's also, and red, and then we're asking the question of red. And red is going to come and blue is going to triumph because it filtered red first, but then it goes and does that inner expression, right? That first expression, so blue wins. Now, if you have, so here's another nested filter. Filter, calculate table, same thing. But here I'm doing, instead of calculate table and calculate table, I'm doing filter calculate table. Anybody going to guess what's going to happen? Well, I say on the screen. It's going to return nothing, okay? So, and if I did filter filter instead of filter calculate table, it returns nothing. And if I do calculate filter, it'll also return nothing. So listen, I have to tell you that I had to do this to understand it, right? I mean, my point is not that you should understand the sequence of what filter filter does, what filter calculate does. I mean, it's great when you finally do. My point is that the order you put crap in matters, right?
So, Rachel,
And you
can
have
you just
to
speak to
understand
your first example there that returned blue?
So
I would have thought that wouldn't have returned anything because calculate table. I would have assumed the calculate table did an implicit filter and that there would not be nothing left.
I don't know. I wouldn't say it would. I mean, basically, it's doing the outer one, and then it filters for red, and it's only got red. That's what it's returning.
Right.
And then it says, but this one, because this is working off of a calculate tables, it overwrites. So blue wins.
Yeah.
When it's a filter, it doesn't overwrite. See, you have to wrap your mind around overwrite versus intersect. It's because I chose here you know, whereas before, when I was showing you above, my choosing of here, of whether I put filter and calculate table, filter and filter, didn't make any difference. In this world, where I'm asking a question of the same column, makes a big difference, because one is going to overwrite, right? And the other one is going to say, these two can't be the same. So, believe me, I had to study this a long time. I'm not getting that.
Well, it's like
anyone
a few other things indexed, it just does.
Yeah. Or you wouldn't, yes.
It doesn't have to make sense.
You have to, right. So my point is more that the reason you want to use DAX Studio is you really want to play around with stuff. Because between speed and the actual order, it'll make a big difference. Okay, so last thing, I think. Okay, so rule of thumb for nesting, filter and all the table functions is inner first, outer last. I kept thinking, like, is there like an inner belly button joke I could get to remember this in my mind? Never really got it. So I'm going to throw one last ringer at you because it'll make me look really smart. But in fact, it's just totally out of a blog. So, so calculate columns, right? You guys know, like in DAX Studio, I'm going to go over to this calculated columns. And so this calculated column, I will see if I can make this a little bit bigger, is simple. It is going and saying, I want the sum of the product list type. I'm in the product table. It's saying, I want the sum of the product list price. Because I've got calculate on there, what is happening? Starts with the C. Context transition, exactly, right? It is saying, looks like I'm in a row, but I'm going to transition to say I'm going to use that row as a filter. That's what context transition is doing. If I didn't have that calculate in there, you wouldn't get the sum of it. Now, they happen to all look like they're the same, but they're not. So if you, 357, right? Yeah. Okay, boom, we got that context transition, we're cool. Now, I go over here and I say, okay, I'm going to do a calculate. You're using the same thing as sum, but I'm going to say all products. And of course, it's kind of intuitive. It gives me the total amount. In fact, it's a little messed up. So in a minute, we'll see why. So those are those two measures, right? Context transition is happening for both. The first one returns just that row price, and the second one returns the total price. Makes sense, right? But you put these two conditions, here's the problem. If you put these two conditions in an and, context transition, which is the more restrictive, should win. It should, the one that said I'm $3,000 should win. Context transition is the more restrictive one in an and clause. So why did we get that big number? Well, in fact, it has two filters. The filter, it's being filtered by context transition, and then it's got that filter of all. And here is one of those conventions, like math. You just have to know the order of precedence when context transition is happening is that calculate is going to go do the context transition first, and it's going to apply the other filters later. As a result, in this one, the later filter was an all, and so that overwrote the context transition. So I know that's a lot to throw at you, but the point is that it's not something to take lightly, order of evaluation, right? Even this would throw you a winger, because in really, if those were just ands, for the same product column, for the same column in the product table, you should get the more limited one, right? So that's the end. So, any questions?
I have a question.
Yeah.
So within calculate, you have the first parameter, which is your expression, but then you can string a whole bunch of parameters within a single calculate function. Does that order also happen there? So if I had the second and
No,
third
that's
parameter
fine.
that cancel each other out?
No, if you can put any order, if it's a different column, or whatever, no, the order is not a problem there. And that's one of the things you'll run in most into the literature. That'll say, so all of this is under, and you can see why I went to the trouble to make this cheat sheet for myself. All of this is under chapter 10 of the big purple book, and so this, which is called Advanced Evaluation Context, and it's like this. It starts on 316. This whole guide to understanding or of evaluation. And he pulls in tuples, and he pulls in what I was telling, intersect, overwrite. So you can see that it's not something you just want to gloss over, right? Okay? All right. Thank you.